Hey, what's up, everyone? Professor Calderon here. And what I wanted to talk about is next is movement. Well, we have two different kinds of movement. We have object movement and we have camera movement. So I gave you the other one about object movement. Now I want to talk about camera movement. So I got some graphics here for you. Camera movement is a little bit more complicated than object movement because a lot of stuff going on here. So there are three different camera moves that create relative movement and the illusion of depth. Okay, and these three moves are the dolly when you dolly in and out, the tracking when you track left and right, the booming up and booming down. So it doesn't matter how the camera is being moved, if it's a crane, a car, a helicopter, whatever, but those same basic principles of the camera moving in and out and dollying up are the same, okay, and left and right. So it doesn't matter what's moving them, the principles are the same, okay. So let's start with dolly in and out. This means the camera is moving into an object and out of it. And what it does is it creates relative movement in the background to the foreground. That means objects in the foreground will appear to move faster. Objects in the background will appear to move slower. Here's a brief example of that right here in this photo. And then as the camera dollies in, I'm sorry, here's an overview map of it. So we have this concept now of what's called relative movement. And in this overhead diagram, the camera position 1, the camera is 6 inches from the subject. I'm sorry, they begin 6 feet from the subject, sorry. And then it is 56 feet from the background. So if the camera dollies in 5 feet, now it is only 1 foot from the foreground subject and only 50 feet from the background subjects. Okay, so the foreground actor or object is now 6 times closer to the camera. So there is a larger increase. Okay, so the closer the object is to the camera, when the camera makes that motion forward, it's going to increase at a faster rate. That node in the mind translates that as a depth cue. Okay, it's that relative size change as well. So conversely, when the camera dollies, say, left and right, we have a different type of relative object movement. Okay, so in this shot, we have the foreground actor and we have the background actors. So as the camera, which is closest to the foreground actor, dollies left and right, the actor will appear to move in the foreground, will move across the picture plane faster than the objects in the background. The brain again interprets that relative movement as deep space. The same thing for dollying up and down. If it's a hand dolly or a helicopter, it doesn't matter. There's relative movement. The objects in the foreground closest to the camera will traverse the picture plane faster than the objects in the background. Okay? Relative movement. And that, again, triggers us to think deep space. Does that make sense? If not, post some questions and I will answer them.